All right, here's worksheet part 2 of 14.5, acid strength Ka general rules. You know, a lot of stuff that is mentioned in the notes, these notes go right along with the book, the Zumdahl textbook that I started all my lessons out when I was teaching in the very beginning. And Zumdahl is great. Well, in this case, they kind of ask some things that are a little bit more, the AP doesn't ask, like a little bit more in detail. That's why on the first part I skipped over some stuff about the stronger, the weaker, and all that. I'm gonna talk about that right now, though. I'm gonna get into it here. The way even this is not really something that pops up a lot for AP, but I'll show it to you. Okay, so I could have called this 14.2b because there it is, comparing acid strength and base strength in water. Okay, so all right. First of all, it says a substance. Is there any calculation here? I can see some stuff. Oh no. H2O is amphoteric. Think about the amph, whatever that word, if it's Greek or something, is like amphibian. You can do two things, water and land animal, right? So water can be an acid or a base. It can actually act as a base or an acid. And here's what happens. I didn't know I was teaching this part right now, but I guess I am. Water, okay. Here's what I want to show you. First of all, you're going to see this equation written somewhere that H2O is in equilibrium and breaks up into H plus and OH negative. So in other words, water can be a base, water can be an acid. And it's both. But it's neutral because they're both equal to each other. Neutral. Well, what this equation, the better way to write this equation is by saying you have two H2Os. An H2O in water, in a glass of water, and I've got some water around here. Well, this has some more than just water in it. But in a glass of water or container, water molecules bump into each other, and they break each other apart. One of them releases an H plus to the other. And so you make H plus, and then it's left as OH negative. I guess if I wanted to write it better, I could say OH negative plus H3O plus. What we're saying is if an H left this, goodbye, H. Well, now, who is left behind? OH negative. That becomes OH negative. That H joins on to the other water to give you H3O plus. This is called the dissociation of water. Now, there is even a constant for this, and this is a short form for how it's written. But that's really what's going on is that reaction right there. And the KW says that hydroxide times H3O plus is the KW. And there's on the bottom there's nothing. If you want to put 1 down there, you could, but you can just leave it like that. Now, I'll have to look at the AP sheet because I kind of forgot which one they put on there. But they either give you that one or I think they give you this one. This is the shorthand form of it. This is the dissociation. Now, everything in acid and base is done at 25 Celsius. Remember, constants are only constant at a given temperature. You change temperature, you change the value. And the KW value is equal to 1.00 10 to the negative, or 1.0, sorry, 10 to the negative 14. 1.0 times 10 to the negative 14. That's a really small number. And in water, just so you know this, since this is actually, something is written not too great there, is it? Yeah, no, I think it's all right there. Okay, in water, the acid molarity is 1.0 10 to the negative 7. And the hydroxide is 1.0 10 to the negative 7. They're both equal, and so we say it is neutral. Because you know negative 7 gives you negative 14. They're both equal to each other. I guess I'm not really telling you that on this section of the notes, but I'm going to bring it up anyway. So you can always remember in that equation, it's going to come back in another lesson later. I don't know why it popped in here. But if H plus is equal to the OH concentration molarity in water, it is neutral water. But now, if I put lemon juice in the water or any other chemicals in the water, I can make it an acid or a base. If the OH molarity changes to be greater than H plus, it is a basic. And if the H plus is greater than the OH, it is acidic. And you know that anyway. Or you might know about that. But we'll be getting into the math of this later on. Okay, and then I wrote on here, let's see, there are 6 strong acids. All the others are weak. Organic contains COOH, the carboxyl group. And I showed you that in the last video, C double bond O to OH. If you attach this to any organic molecule that's carboxyl, then you make it an acid, an organic acid. Uh-oh, I gotta find more chalk. Okay. Oh. Oh boy. Hey. It fell. All right. Let me take all this away. That stuff I just showed you, the KW, 1 times 10 to the negative 14, it's going to become very important later on, but I don't know. For some reason I put it in the notes here. Now, it says comparing the strong bases are, and I have that written there too, all the soluble OH hydroxide. So everything in group 1, remember all of group 1 dissolves. So that means lithium hydroxide, strong base, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide, francium hydroxide. Those are all strong bases. And then the ones that dissolve in group 2, the camel with straw on his back, those are the only other hydroxides that dissolve. Those, you could consider those mainly calcium hydroxide. You don't hear too much about strontium and barium, but you know, you could argue that those are strong bases. Probably not ever going to see those on the AP. In fact, on the AP, the only 2 strong bases they really use are sodium hydroxide, potassium hydroxide. Maybe lithium's been on there once, lithium hydroxide. Okay, comparing by general definition. Identify the following as strong acid, strong base, weak acid, or weak base when placed in aqueous solution. Okay, so the first one, CH3CH2COOH, okay, that's actually... that would be propanoic acid. Yeah, that is an organic acid. Okay, CH3COO, that one. Because you see the CO2H, the carboxyl. If you looks like this in the Lewis dot diagram, or it looks like this sometimes on an organic formula. It'll be something CH3COOH, or it could be CO2H. See how they write that? So if you see that in the formula, at the end of it, really, is where you're going to see it. That's an acid, acid, acid. And, of course, that means it will lose the H plus, and it'll be left, like in this case, with a lone pair, and it'll be -1. It'll lose the H plus, and now it becomes -1. It'll lose the H plus, it'll be CO2 -1. So there's just different ways they write it. Number B, H3PO4, you know that's a weak acid. LiOH, strong base, okay? HI, strong acid. You had to memorize that. 3, oh, that one has it hidden inside there. CH3, CH, CH3. Methane, propane. Propane. It's 2-aminopropane. 2-aminopropane, and it will be a base because that CH3, CH, NH2, CH3 can convert into CH3, CH, NH3 plus. 3 NH3, CH3 plus. Normally they put the NH2 at the end because that way you see it when it gains an H. It's a base. It's a weak base. Weak base. F is also a weak base, okay? And you've seen that over and over, but it's not bad to keep looking at it again. NH3 in water will give you NH4 plus and OH negative. And then H3O plus. Okay, now this is where I haven't really seen this on the AP before, but you need to know. H3O plus is, by definition, it is acid. It is the acid, the strongest of all acids. If I poured, well, I will tell you this in a minute. I'm not going to be evil to you, no way. But 1 molar will burn you enough. It won't burn you. It'll like burn. I don't know, you can wash your hand off a little bit, like sting a small bit. Like maybe worse, maybe not as bad as even an ant bite. Okay, but if you poured 1 molar HCl on you, okay, think about how that would burn you. Well, if you could pour 1 molar H3O plus on you, that would be even more H pluses than this. Remember, this is going to be about 100%, but not all the way. So you're going to get almost all the H pluses, but not all of them. But this is all H pluses. So hydronium, the book talks about how H3O plus is the strongest acid species of anything. H3O is stronger than HCl, stronger than HBr, stronger than HI, HNO3, all of that. Okay. Now it says, that's actually on the next little frame there. H3O plus is the strongest acid that can exist. Well, the acid, I should say species. We don't really see H3O written that much, like in a Ka. I mean, it could be done. And I wrote there. Okay, I wrote the same thing I just told you. Okay, so strong acids have very high number for Ka values, like 1 times 10 to the 58. But weak acids have small ones, like 1 times 10 to the negative 58. Okay, strong acids have weak conjugate bases, and weak acids have strong conjugate bases. Okay, H2O is a stronger base than the conjugate base of a strong acid. Now here's a weird one. So here I'll show you a weird thing, but a weird way to say it. But I'll mention how it works. Okay, we would say here H2O is a, what did it say, stronger base than the conjugate of a weak acid. Okay, here's what it means. A base, being a good base, strong base, means you holds on best to H plus. Okay? A strong base means it holds the stronger. No, I don't want to say strong because I told you OH negative. The stronger base is the one that holds on best and keeps the H plus. All right, so think about this. If we put this in water, as we said on the last video, almost 100% of it is going to be H plus, actually H3O plus, H3O plus, H3O plus, H3O plus, Cl negative, Cl negative. That'll be in there as well. And we can put Cl negative in there too. And we'll have a little bit of HCl, almost nothing. We'll just say almost all of our H3O plus and Cl negative. Okay, almost all of this is what you have. Okay, now here's the deal. So who are the bases in this system? The bases are actually water and chloride. How do you know that? Because this is an acid. That's its conjugate base. This is an acid. And here's its conjugate base. So between the two bases, who is the stronger base? Okay, it's the one that is better at holding on to H plus. So in this solution, who is holding on to H plus? In reality, all right, it will be the almost everything is H3O. Water is holding on to an H plus. This base is not letting go of H plus because this is not seen, but it's inside this. Okay, this is the form that you have. So I know that's an acid, but the base is holding on. This is the strongest base. Another way to look at it is chloride is not holding on to anything. I only have one molecule where chloride is holding on to H. So all the chlorides are away, very weak. They just let everything just falls off of it. So in fact, there's a little statement that the negative ion, the negative ion of a strong acid is the weakest possible base. All right, remember the conjugate of a strong acid is a weak base. Well, the conjugate of HCl, strong acid, is the conjugate of a strong acid is the weakest conjugate base. The only thing, it's weaker than anything. Even water is a stronger base than the conjugate of that. So H2O is a stronger base than Cl negative. What a weird thing to kind of phrase it that way. All right, and I wrote it down here at the bottom. H2O is a stronger base than the conjugate base of any strong acid. Okay, all right, and then H2O is a weaker base than the conjugate of a weak acid, and I'll have to show you that one as well. Well, I guess yeah. Let me just keep that up there and try and show you. So for a weak acid like H, this time I'll use the other form, CH3COOH of acetic acid, because again they use both on the AP. That one plus water gives you, of course, H3O plus, and it should be equilibrium, sorry, and CH3COO negative. Okay, so here's the deal. acid base, who's a stronger base and weaker base. It talked about the bases here. So the same thing. This is your acid. Here's your conjugate base. Here's another acid, and here's its conjugate base. Okay? So the two bases here are H2O and CH3COO negative. So again, who is doing a better job at holding on to H plus in a solution of this? Now remember, in a weak acid, this is the one that I hate to draw all the stuff on it, but almost all the molecules in here are CH3COOH. Remember? Almost all of them, hardly any of them dissociate or break up. It might only be 4%, 5%. I mean, even if it were 20%, that's still very, very small. So almost every molecule in here says that Chku is holding on to H+. Chku is connected to H+. Look at that. I'll draw it that way. So notice all of these are holding on to an H+. That means who's a stronger base? The stronger base is the one that holds on better to H+. In the solution, you have almost all of these Chkus are holding on to H+, because they're in this form. So the stronger base is CH3COO negative. The weaker base would be water. Water is not holding on because you don't have very much H3O plus at all. You have lots of water, and there's only a little bit of H plus in a weak acid. Okay? So all the, I did 3 molecule H plus, 3 H3Os, we'll pretend. But all the other water molecules are just alone, not holding on to anything. Okay, so that's why it says H2O is a weaker base than the conjugate of a weak acid. Okay, so that's weird. So a strong acid, its conjugate base is a weaker base than water. But for a weak acid, its conjugate base is a stronger base than water. Okay. Now, these are the conjugate, these are the values for them as well, for the acids. And one way to tell who's a stronger acid would just be simply to say who has a higher Ka value. I didn't put HCl on here because it's a strong acid. But like the strongest acid listed here would actually be 1.2. Looks like, I don't even know what this is, but this third one. This one with a ClO2 at the end of it. 1.35 10 to the... That's wrong. The one below it. Oh, that would be chlorous acid. The one 10 to the negative 2. That one. That one would be, HClO2 would be the strongest on the page. 1.2 10 to the negative 2. Because that number, 10 to the negative 2, is higher. You got to think about your negatives. 10 to the negative 2 is higher than any of the other numbers that are on there. They're all 10 to the negative 10. There's one more 10 to the negative 2, 1.2. But, it's actually, there's a tie. I didn't see that. HSO4 negative is also the same as that one. So they will both be the strongest weak acid. Okay, so now let's go through letter E. So this is interesting, and this is more like, for me, like a little multiple choice thing. And it could be somewhere, probably is in a multiple choice on AP. But I can tell you, I don't remember seeing this on any essays. And I'm not going to give you an essay on this. But, okay, letter E. It says, which is the stronger acid, HCN or HClO2? So here you just have to look at the at their values. HCN is 6.2 to the negative 10. HClO2 is 1.2 to the negative 2. So the stronger one would be that. That's a higher Ka because it has a higher Ka value. And if they didn't, I'm wrong. They have asked things on the AP, like maybe in an equilibrium problem, A, B, C, D, E, F, and they'll say which is stronger, and that's a good way. That's one way to do it mathematically. Having a higher Ka value means you're a stronger acid. This acid with the other acid. The other ones I was trying to do something to show you Ka and Kb together, but you can't mix them that way. All right, HCN or H2O. Okay, what is a stronger acid? Okay, so for this one, here's what you have to approach it with. And I told you, if you wanted to write down, if it helps you to write down the reaction, HCN plus water gives you H3O plus and Cn negative. Now remember, the stronger acid is going to be Okay, we didn't talk about base. Stronger acid is the one that's better at releasing the H plus. Okay, so we know that's a weak acid. And if you look in this one, well, that's a stronger. As an acid. I'm so sorry about that. I'm so sorry as an acid. As an acid. Okay. Where does the equilibrium position lie for this? Okay, it's almost all on the right. The left. Sorry about that. Left. Almost everything in here is HCN, 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 HCN. You only have a little bit of H3O plus there. Okay? So what it tells me is that water, remember we talked about water is the weakest of all acids. Okay, it's really not good at holding. That would be a base. That's the base. It is the weakest of all acids. I'll just tell you that statement straight out. It's the weakest of all acids, and it's the weakest base except for the conjugate of a strong acid. So H2O, there are some bases that are weaker than H2O. Only a few. Cl negative from HCl, Br negative, I negative, nitrate, those, okay? The conjugates of strong acids. But there's no other base. And it is the weakest acid of all. So it doesn't do a good job. This equation doesn't really do a good job of showing you. But what we're saying is that it doesn't go, H2O doesn't give you OH. It doesn't release H plus at all. So only that one would release it. And that one would really be the strongest, okay, of all. The strongest species here. But they don't really ask about that one too much. We know that this is releasing some. So the stronger acid, the stronger acid for sure is HCN. So for that one, okay, HCN is, sorry, what in the world? I am so sorry that I drew that. No, I did it and I meant wrong. It was wrong. That's a stronger acid. Every acid is stronger than water as an acid. That's what we mean. Yeah, that's what I was trying to get at. Okay. I guess I didn't really have to draw it. I was going to start to show you about the conjugate base, and I realized, no, that's not the base. But still, there is no H. If there were OH negative in there, then you know that it's acting as an acid. It's releasing, but it's not. Okay, now, which is a stronger base, part 2? This part might be a little bit more exciting. Oh, and maybe I do need that equation for this one. Oh, my goodness. I think I have a problem with this eraser falling apart. Okay, what is a stronger base? OCl negative or ClO negative? ClO2 negative. Okay, so here's what you have to do. First, you would say, are any of them strong? Did any of them come from strong acids? HOCl is a weak acid. HClO2 is a weak acid, so that doesn't work. The next thing you got to do is now I'm going to have to look at their Ka values. Okay, I'm going to look. Actually, let's think about this for a minute. Who's the conjugate of this? The conjugate of that is HOCl. Who's the conjugate of this? It's going to be HClO2. So now I've got to find those in the number values right there. For HClO2, the number value is 1.2, 10 to the negative 2, Ka. For HOCl, the value is 3.5, 10 to the negative 8. Now, here's how it works. We're comparing bases here. Remember, a weak acid will have a stronger conjugate base. The weaker acid has a stronger conjugate base. The stronger acid has a weaker conjugate base. Okay, so the stronger one is a higher number. That's a stronger one. So that means it's a stronger acid. So the base form, the conjugate base, will be weaker. So that should be weaker, and that should be stronger. This is a negative 8 acid, 10 to the negative 8. That's a weaker acid. So the weaker acid, its conjugate should be a stronger conjugate base. Let me see. Yeah, now my numbers do work. I was going to calculate something earlier. But a weaker has a stronger conjugate base. And a stronger conjugate base. Well, anyway, I'll have to look back. I was going to show you something of the lesson, but I didn't. I abandoned it. But I better, it'll come back later on and I'll show it to you the right way. I was trying to use an example in the wrong place, but this is a good way to do it. So remember that number, that's the stronger acid, so that means it has a weaker conjugate base. It's smaller, and the stronger conjugate base has a weaker the weaker conjugate acid has a stronger conjugate base. Okay, all right, that's the way. There's another math thing you can do, actually, and I'm going to teach it to you in a lesson coming up later, that you can actually, I'll just tell it to you right now, because you might as well know it right now. This is a very important equation, very, very important equation. It's math that's going to come up later. Ka times Kb equals Kw. What that means is Ka times Kb equals 1.0 times 10 to the negative 14 at 25. Remember I told you. Well, there's even a better thing. Here's how I like to write it. Ka of an acid times Kb of its conjugate base equals that number. So Ka of an acid times the Kb, or for that matter, how about this? This works for both. Conjugate acid, conjugate base. If conjugate acid, conjugate base, conjugate acid, conjugate base, I can calculate the Kb if I know the Ka and I know this number right here. I can just this divided by that. So this will always be true to mathematically calculate it. And if you calculate them both, mathematically you'll see this is a stronger base. It has a higher Kb value than that one does. That has a lower Kb value. So that's a mathematical way you can do it. And you'll see it later on. But I wanted to bring that up right now and just tell you, when we get to the math later, acids and their conjugates, bases, actually have a value, a number value. Okay, so we're moving on. Cn negative or H2O. Oh, I got HCN up there too. Well, let me just see if I'm going to keep that there or not. All right, if I have Cn negative or H2O. Well, remember I told you this. Water is the weakest. Just remember it out this way. Water is the weakest of all bases, okay? The only base, well, it's almost the weakest of all bases. The only thing that's weaker as a base is the conjugate of a strong acid. This is the conjugate of a weak acid. So therefore, that means this is a weak acid conjugate. So that means that it'll have a stronger base, and so it's going to be stronger. Water will be weaker than weakest base of all. As a base, this will be weaker than all the bases except for, what does it say? Except for the conjugate of a weak base. I know there's another way I could probably draw this to help you out. The weak acid. Well, I better not. I better just leave it at that. Just let you just memorize it. Because as I said, it's not something that I see pop up on AP. All right. That in that way, written in that way. Okay. Now, Br negative or H2O. Okay, for that one, for Br negative or H2O. Now, this is the conjugate of a strong acid conjugate. So that means that water will be a stronger base than the conjugate of a strong acid, because HBr is a strong acid. Okay, now it says, based on the data given, letter F, arrange the following in order of increasing strength as acids. You know, this is taking me a lot going through all this, but hopefully the homework will be pretty short and easy. This is a really important thing that you can do this. They love to do this on AP. Arrange these in order of increasing acid strength. When it says arrange something in order of increasing acid strength, just think of it this way. That means, okay, increasing. That means this will be the weak acid, weakest, whatever, weak acidic, and this will be the strong. So increasing means I want to go from weak to strong, to stronger, or we'll just say it that way. So first I'm going to look at those and see, is there a strong acid in that list? Yeah, there is. HCl. Almost said something else, and there it is too. But remember, H3O plus is the strongest species of the strongest acid species. So that will be the strongest, and that will be the second strongest. Okay, all right, what do we know about water, H2O, an acid? Okay, I told you, water is you just have to memorize the statement. It's the weakest acid of any at all. It never releases. I mean, if you ever have an acid environment, if I put HCl and H together, if I put vinegar and H2O together and vinegar, if I put H2O and HCl together, who's going to be the one that releases the H plus? It's going to be those acids. The weakest acid is H2O. So H2O is the weakest of all. All right, so we're kind of doing elimination there. 1, 2, 3 are out. Now we're left with HF, HNO2, and HCN. And so now I'm going to look at their Ka values to do this part. And this is more like the part that I see on AP that they ask you about. HF, 7.2, 10 to the negative 4. HNO2, 4.0, 10 to the negative 4. And HCN, so just reading a data table and knowing how to interpret it, 6.2, 10 to the negative 10. So who's the weakest of all of these? Well, the weakest has to be the highest number, HCN. So HCN will be stronger than water, but weaker than any of these. Then these two will be next. And who's stronger? HNO2. Because now they're both the same power, 4, and that's the greatest. So HNO2, oh no, I'll just try to squeeze it in there. HNO2, and then stronger than HNO2 is HF. HF. That looks kind of funny. All the weak ones, and now suddenly a strong HCl. I wouldn't normally write it that way. I just wanted to fit it there. So water is the weakest, then HCN, HNO2, HF. These three, because the KAs tell you, bigger number, middle, smallest, small, middle, bigger. And then HCl is the strongest acid, except that's the strongest acid species, H3O+. Okay. Now, we will do letter D. Based on the data given, now arrange the following in order of increasing strength as a base. And I wrote for a hint, write the equation with water. I might not want to do it. We might not have to do that, but we might. We'll just see. Let's see if we can just figure it. I think we can figure it out. I hope. We'll see. We'll do it for some of it maybe. Okay, so do we see anything on there that's a strong base? Remember, strong base, hydroxide. OH negative. That's the strongest of all. So strong base, stronger base, weaker base. Oh, I meant to say, I like to write that on my paper. Weaker is, if it says, arrange sometimes it'll say, arrange in order of decreasing acid strength, or in order of increasing acid strength, or increasing base, or decreasing base. So if it says increasing, that means I go from small to large, or from weak to strong. So I just, on my paper, I write smaller, larger, or weaker, stronger. I just like to do that because it just helps me to make sure I'm going in the right direction. Stronger is OH negative. The weakest base. Can you remember I told you the rule a moment ago? The weakest base is water, usually water, except for the one thing that's weaker would be the conjugate of a strong acid. Do you see the conjugate of a strong acid? To find the conjugate, just add H to all those. Or H2O, well, I don't need to do that. H3O+. If I add HF, okay, it's a weak acid. HCl, strong acid. So Cl negative is a conjugate of a strong. So that's the weakest base. That will be the next weakest base, or stronger, how you want to look at it. Stronger than that. The stronger, not the next weakest, but the stronger base. All right, now we've taken those out. We're left with, and it just as and I took them away last time. But look, actually I can do it here. CN, HNO2, and HF. We did these by their Ka values, remember? And here we see CN negative. We see NO2 negative. NO2 negative. And we see F negative. So, remember what I told you a moment ago. A stronger acid will have a weaker conjugate base. A weaker acid will have a stronger conjugate base. So, if this is the strongest, who is the strongest of all the acids that has the highest Ka value? That means this is going to be the weakest base of all three of these. So it'll be just the opposite. That will be, it's stronger than water, but it's going to be weaker than these three. Okay, F. That one will be in the middle. And because HCN had the smallest Ka value on the paper. Its Ka value was 6.2 10 to the negative 10. That means its CN value, the Kb will be greater than the other two. Okay, it's a stronger base. Or another way to look at it is, well, yeah, that's all. If it's weaker, then its conjugate will be stronger conjugate. So I didn't really have to draw an equation for that. the hint draw an equation, that doesn't really help with it. I think it's just better to memorize and know that way. But as I said, the main thing that I see on AP is they give you the KA numbers. But I will ask you about this. I do want you to know how to do it anyway. I mean, because what if they did ask it on AP? I want you to be ready for that. All right. Well, so do all the worksheet, and that will be it. And I will see you guys later.